Well, so today we will talk about some concepts of complex number. We will also discuss about a few questions which previously came in previous year JEEs from this particular chapter. All right. So first of all, I'll start with I'll start with certain concepts of this particular chapter. All right. As such, you have done it. You know what is a complex number. You must be knowing what is its real part, what is its imaginary part. So all those terms you are very well aware of. Now I'll talk about certain properties of the complex numbers. And in those properties, also the most important property is, most important property first of all. Most important property of a complex number. I mix few things. Number one is, if z is x plus iota y, then z conjugate is x minus iota y. This is very simple and we all are aware of this fact. Got it? So if z is x plus iota y, then z conjugate is x minus iota y. Second, magnitude of z is under root of x square plus y square. And from this you can confidently say that magnitude of z square is z bar. Very, very, very important. Very, very important. Magnitude of z square is z bar. Now see, just a moment. Now see, let's do a question on this property. And there is a question in previous year JEE, that is this one. Let z is x plus iota y be a non-zero complex number such that z square is iota times mod z square. So the question is, z square is iota times magnitude of z square. Now see, we can say that this z square is iota times this mod z square is z bar. Yes or no? So this z square minus iota times z bar is equals to 0. If you take z common, you get z minus iota z bar is equals to 0. Now one option is that z equals to 0. Z equals to 0 means 0 plus 0 iota. Got it? Other option is z equals to iota z bar. Now if z is x plus iota y, then z bar is x minus iota y. So it will become x plus iota y is iota x plus y. Now if I compare their real parts as well as their imaginary parts, I ultimately end up with equation like x equals to y. Now this x equals to y itself cover this 0 plus 0 iota solution. So the answer will be what? Answer will be this. Am I clear? And see how simple this question is. Got it? So the answer is the line y equals to x. Now, let's talk about more properties. Property number 4. If z equals to z bar. So if a complex number is equals to its conjugate, that means what? Means z is a purely real complex number. Got it? So if a complex number is equals to its conjugate, that means it is purely real. Fifth part, if z plus z bar is 0. If z plus z bar is 0, means a complex number plus its conjugate is 0. Means what? Means z is purely imaginary. So if z equals to z bar, that means that complex number is purely real. If z plus z bar is 0, that means the complex number is purely imaginary. Am I correct? Now, the sixth part, sixth property. See, let us assume there is a complex number z. Now, what will be this length? This length will be magnitude z. If this z is x plus iota y, that means this length is x, this length is y. So mod z will be what? Under root of x square plus y square. Now if this angle is theta, am I correct? So this z, which is x plus iota y, I can write this x as magnitude of z cos theta. This y as magnitude of z sin theta. So this is x can be written as mod z cos theta plus iota times mod z sin theta. So this is mod z times cos theta plus iota sin theta. Now this theta is what? This is argument of the complex number. This z is what? Mod z. This is magnitude of complex number. Now if you see, this z can also be written as magnitude of z e to the power iota theta. What did I do? This e to the power iota theta means cos theta plus iota sin theta. This is what we call Euler's form. Euler's form of writing this complex number. Got it? So this is what we call Euler's form of writing a complex number. So whenever they are giving a big expression of a complex number and then they are saying this is purely real. So what simply you can do, you equate that complex number with its conjugate. If they say this is purely imaginary, you take its conjugate, add both of them and then make it 0. Got it? Like there is a question. See this one. They are saying 3 plus iota sine theta upon 4 minus iota cos theta, theta lies between 0 to pi, is a real number, then an argument of cos theta plus sine theta plus iota cos theta is. Alright. So let's do how do we do it. They are saying that this complex number is a real number. If it is real number, that means it is equal to its conjugate. 3 plus iota sine theta upon 4 minus iota cos theta is 3 minus iota sine theta upon 4 plus iota cos theta. If complex number is purely real, it means it is equal to its conjugate. Got it? Now let's cross multiply it. So it will be 3 plus iota sine theta, 4 plus iota cos theta is 3 minus iota sine theta, 4 minus iota cos theta. So it is 12 plus 3 iota cos theta plus 4 iota sine theta minus of sine theta cos theta is 12 minus 3 iota cos theta minus 4 iota sine theta minus of sine theta cos theta. You got this? Now this 12 cancel, sine theta cos theta cancel. So what I'm left with 8 sine theta, 8 iota sine theta is minus 6 iota cos theta. Am I correct? So it will be like tan theta is minus of 3 by 4. Tan theta is minus of 3 by 4. Now they're asking for the argument of sine theta plus iota cos theta. Now I can also, see, argument is what? While it is cos theta plus iota sine theta, not sine theta plus iota cos theta. Am I correct? When do we talk about argument? Argument is theta when it is in the form of cos theta plus iota sine theta. So I can write it cos pi by 2 minus theta plus iota sine pi by 2 minus theta. So argument is what? Pi by 2 minus theta. Got it? So, and that is also 2n pi times rotated because argument is repeating after every interval of 2n pi. So it is 2n pi plus pi by 2 minus. Now your theta is tan inverse of minus 3 by 4. Got it? So it is 2n pi plus pi by 2 plus tan inverse of 3 upon 4. Now I do one thing. I add pi by 2. I subtract pi by 2. So it is 2n pi plus pi minus. Now if you take minus common, it is pi by 2 minus tan inverse of 3 by 4, which is cot inverse of 3 by 4. So this will be what? 2n plus 1 pi minus. Now this cot inverse 3 by 4 can again be written as tan inverse 4 by 3. And if you put n equals to 0, it will be pi minus tan inverse of 4 upon 3. Got it? There are one or two properties which you might not be aware of. Got it? So the properties which I have used it extra, which you are not aware of, is like tan inverse x plus cot inverse x is pi by 2. You guys are not aware of this property, I think. Another property that I have used here is tan inverse x is cot inverse 1 by x. Tan inverse x is cot inverse 1 by x and tan inverse x plus cot inverse x is pi by 2. These are the two properties which I have used here. So answer is pi minus tan inverse of 4 by 3. Got it? So this was a easy, simple question, I would say. Fine. Now, am I clear? Now we'll come back to the properties. All right. Now I'll give you one or two simple, better questions. See, a question is, this is a question from JEE Advanced once upon a time in 2012. Let Z be a complex number. Let Z be a complex number such that imaginary part of Z is not equal to 0 and A is Z square plus Z plus 1 is real. Then A cannot take the value. A cannot take the value. Options are -1, B is 1 by 3, C is 1 by 2, and D is 3 by 4. Okay, give it a try. I give you a couple of minutes to solve it. All right, solve it and mark your answer in the poll. All right, most of the people have marked their answer as C. Others, please try. I'm very happy that 10 people have participated in this contest. Well, now let's see. This is the question. They are saying A is real. If A is real, that means A is A conjugate. So Z square plus Z plus 1 is Z bar square plus Z bar plus 1. Am I correct? Now this 1 cancelled. So you get Z square minus Z bar square plus Z minus Z bar is equals to 0. Got it? Now from this Z minus Z bar came common. So it is Z plus Z bar plus 1 is equals to 0. Now one case is Z equals to Z bar. Got it? So if Z equals to Z bar, that means Z is a purely real complex number, means its imaginary part is 0. But in the question they are saying that imaginary part of Z is not 0. So that means this situation cannot occur. So Z plus Z bar is equals to -1. Am I correct? So z plus z bar is equals to minus 1. Now let us assume z is x plus iota y. So x plus iota y plus x minus iota y is equals to minus 1. So x is what? Minus 1 by 2. So they are saying z be a complex number such that, and this is real, then a cannot take the value. Now, if x is minus 1 by 2, then a will be what? Minus 1 by 2 plus iota y whole square minus 1 by 2 plus iota y plus 1. So it is 1 by 4 minus y square minus iota y minus 1 by 2 plus iota y plus 1. This iota y cancel. So it is 1 minus 1 by 4. It will be 3 by 4 minus y square. Now see, value of a will be 3 by 4 if y is 0. And according to the question, imaginary part of z is non-zero. That means value of a can be anything except what? 3 by 4. So this is your correct answer. Got my point? And this is the answer which only one person marked. Rest nobody did. Got it? And this is a good question. Very conceptual also. Fair enough? If you guys got answer, or if you understood it, you can just put a thumbs up so that I can feel like we have an interaction. Yeah, somebody is asking me to like go for it once again. Yeah, please see. Z be a complex number such that imaginary part of Z is never zero. Very good. Now this is purely real. We will go only with the basic concepts, nothing new. If a complex number is purely real, that means it is equal to its conjugate. Got it? So z square plus z plus 1 is z bar square plus z bar plus 1. Fair enough? So 1 cancel. It became z square minus z bar square plus z minus z bar equals to 0. Now from this z minus z bar common, you got z plus z bar plus 1 equals to 0. Am I correct? Now z minus z bar, if this is 0, that means z equals to z bar. So if z equals to z bar, that it stands like z is purely real, means its imaginary part is 0. But in the question they are saying imaginary part of z is not 0. So this cannot happen. That means z plus z bar is minus 1. Got it? Now if z is x plus iota y, then z bar is x minus iota y. So z plus z bar will be 2x. So 2x is minus 1. So x is minus 1 by 2. Got it? If x is minus 1 by 2, implies z is minus 1 by 2 plus iota y. Now I put it here. So a is minus 1 by 2 plus iota y whole square plus minus 1 by 2 plus iota y plus 1. I put z here. Now if you simplify it, you get 3 by 4 minus y square. So value of a will be 3 by 4 if y goes 0, but y is never 0. Imaginary part of z is non-zero. So if this is non-zero, this means this y cannot be 0. This means this a can never be 3 by 4. So a never 3 by 4. So this a cannot take value as 3 by 4. Have a look at it. Absorb it totally. Write it down. Note it down. Very good question. Got it? Now, let's do another very good question which came in J Advanced once upon a time. The question is, let z equals to x plus iota y, where x and y are integers. Integers. Find the area of the rectangle. Find the area of the rectangle whose vertices are the roots of the equation z bar z cube plus zz bar cube is equals to 350. Find the area of the rectangle whose vertices are the roots of this equation z bar z cube plus zz bar cube is equals to 350. Yes. Options if you want. A option 48, B option 32, C option 40, D option 80. So take 2 minutes time, go through it and mark your answer in the poll if you get the correct answer. Yeah, please attempt it. Yes, please try. You guys participate well, but this is not such an easy question that you can mark your answer in a moment. Few of you marked answer A, rest marked answer C. Nobody is going with BD. Now we have a volunteer for D also. Very good. Now see, let me start. This question involves a different kind of concept, but such an easy, not too tough. Nothing much to do, just you have to make one or two cases. See, given is z bar z cube plus z bar cube is 350. Now if you take z bar common, you get z square plus z bar square as 350. Now if I assume z is x plus iota y, which is mentioned in the question also, then z bar will be what? Z bar will be x square plus y square. Z square will be x square minus y square plus 2 iota xy. And z bar square will be x square minus y square minus 2 iota xy is equals to 350. Now this 2 iota xy cancel. So it is x square plus y square into twice of x square minus y square is 350. So it is x square plus y square into x square minus y square is 175. Correct? Now since x and y are integers, so x square plus y square will be an integer, x square minus y square will also be an integer. Now I will have to make cases that like how x square and y square can assume values. Alright. See, one case is if I take x square plus y square as 175 and x square minus y square as 1. If you add both of them, you get 2x square as 176. Means x square as 88. Got it? Now x square 88 does not give you x as an integer. So this case is rejected. Am I correct? Now another case. This is not divisible by 3. So another case will be if I take x square minus y square as 5 and x square plus y square as 35. Again, if you add them, you get 2x square as 40. So x square as 20. Again, this value of x square 20 does not provide x as an integer. So reject this one also. Am I correct? Now, as in another case, you can take x square plus y square as after 5, 6, 7, it can be 7. So it is 25 and x square minus y square is going 7. Now if I add both of them, I get 2x square as 32. So x square as 16. Now if x square is 16, so y square goes 9. So x is plus minus 4 and y is plus minus 3. Am I correct? So with these values of x and y, I get 4 points. That is 4 comma 3, 4 comma minus 3, minus 4 comma 3, minus 4 minus 3. Got it? So if you make a rectangle, so like this point is 4 comma minus 3. This will be 4 comma 3. This will be minus 4 minus 3. And this will be minus 4 comma 3. So this one side will be of what length? 6. And this side will be of length 8. So area of the rectangle will be 48. A is the correct answer. Have a look at it. Again, absorb it, note it down. Very good question it is. This question came in JEE Advanced 2009. Check it out. Got it? Check quickly, see. Done? Now, now see, there is a question. This one. Let Z be a complex number such that magnitude of Z minus iota upon Z plus 2 iota is 1. For this one, sometimes they use the word unimodular. Got it? So they can also say it like Z minus iota upon Z plus 2 iota is unimodular. So unimodular means its modulus is 1. Got it? So unimodular is like its modulus is 1. So they are saying complex number such that mod z is 1. Sorry, this z magnitude of this complex number is 1 and magnitude of z is 5 by 2. Then the value of z plus 3 iota is. So the question is magnitude of z minus iota upon z plus 2 iota is 1. Got it? That means the square is also 1. So z minus iota and z plus 2 iota into its conjugate z bar plus iota upon z bar minus 2 iota. This is 1. Now if I multiply it, I get zz bar plus iota z minus iota z bar plus 1 is zz bar minus 2 iota z plus 2 iota z bar minus 4 iota square. So it will be plus 4. Got it? Now this zz bar cancelled. So we got 3 iota z minus 3 iota z bar is equals to 3. So that means z minus iota z bar is equals to 3 is equals to 1. Just a moment. Iota also cancelled. So it is z minus z bar iota times is equals to 1. Now, if z is equals to x plus iota y, that means x plus iota y minus x plus iota y is equals to 1. X cancel. So 2 iota square y is equals to 1. So y came minus 1 by 2. Because iota square is minus 1. So y came minus 1 by 2. Now they are also providing you under root of x square plus y square is 5 by 2. Got it? So x square plus y square is 1 by 4 is 25 by 4. So x square is 24 by 4, that is 6. So implies x is what? Plus minus under root of 6. Now they are asking for the value of z plus 3 iota. Now z is what? Z is root 6 minus 1 by 2 iota. So z plus 3 iota is root 6 plus 5 by 2 iota. So magnitude of z plus 3 iota is under root of 6 plus 25 by 4. So it is 49 by 4, that is 7 upon 2. This is your answer. Am I clear? Now, even if I take x as minus root 6, you would have got the same answer. Check once. Got it? Done? Now, one more question we'll do today. See, if z is a complex number satisfying real part of z plus imaginary part of z is 4, then magnitude of z cannot be. All right, give it a try. I will leave it for you for the time being. Couple of minutes you get to solve it. There is a poll for you. Solve, get your answer, mark in the poll section quickly. Okay. Others, please also. Very good. So we got 4 people have answered it. Each one answered one option. One answered A, one B, one C, and one answered D. Chalo, let's see. This is a simple question. It is. So the question is this. If I assume Z as x plus iota y, that means they are saying mod x plus mod y is equals to 4. Am I correct? Then magnitude of z. Magnitude of z is what? Under root of x square plus y square. I replace one of x or y here. So it is x square plus y square will be 4 minus mod x whole square. So it is 2x square minus 8 mod x plus 16. Am I correct? Now if you take root 2 outside, you get x square minus 4 mod x plus 8, which I can write root 2 times. Inside the root, it will be mod x minus 2 whole square plus 4. Correct? Now, see, this quantity is always greater than or equals to 0. Yes or no? This mod x minus 2 whole square, it is always greater than or equal to 0. That means magnitude of z is always more than or equals to 2 under root 2. Or I can say that this mod z is always more than or equals to under root of 8. So if it is more than or equals to under root 8, it can never be under root of 7. Rest everything is fine. So this is your answer because they're asking magnitude of z cannot be. So if it is cannot be, answer will be root 7 in this case. Got it? Now see, from this question, I've shown you so many, from this chapter, I've shown you so many questions. You might not have done maximum number of questions up to that capacity. Getting my point? You might not have done maximum number of questions up to that capacity, but still questions are not too tough to handle. All right, guys. So that would be all. I think I tried to give you quite an insight of this chapter. Now watch this video again, try more questions over it. Got it? And now I will be like